All right, welcome back, everybody to the immediate track of the NRP Winter 2026 training. Thank you very much for joining us today. So the agenda for today is going to be discussing deploying Jupyter Hub and how to use NRP's Jupyter Hub and Coder. My name is Mohammed. I work at the San Diego Supercomputer Center, and along with me is my colleague Daniel Diaz from the San Diego Supercomputer Center as well. And we have as a facilitator our colleague Dima Mission from the San Diego Supercomputer Center as well. And we mainly work on the National Research Platform. We're user-facing and system-facing. So if you face any issues and you reach out to us in support, most likely you'll reach one of us and we'll be able to help you with any issues you face. For today's training, the agenda is that we start at 05, so we've started at the 45-minute mark. We will go into a brief Q&A for any questions you have for 10 minutes, and then from 11:55 to 12, we're going to have a 5-minute break. The second hour is the same, 45 minutes of training, then 10 minutes of Q&A, then a 5-minute break. Of course, Q&A is voluntary, so you can have 15-minute breaks if you want. And of course, no attendance is mandatory, so feel free to leave and watch the recordings and feel free to come in and out however you please. And the third hour, it's also 45 minutes, then 15 minutes of Q&A. And to get started, just if anybody's joining us new today and you haven't used NRP before and you're not familiar with what NRP is, just to give you a brief introduction. So I'll send the link for this material and you'll be able to join, but to go over it, here's the link in chat. It's all hosted from GitHub. So this is a GitHub page from nrp-nautilus.github.io. This is the entire link. Sent it in chat, and if you're watching the video, you can note it here. And NRP, to give you just a brief recap, is short for the National Research Platform, which is a partnership and a collaboration between multiple institutes. It's primarily led by the University of California at San Diego and the San Diego Supercomputer Center, and the University of Nebraska at Lincoln, and the Massachusetts Green High Performance Computing Center, or MGHPCC, if you're familiar with them. And between those three institutes, we lead the platform and the original set of hardware and infrastructure that started the platform. And along with our collaborators and institutes that contribute resources, we have the entire community-driven platform. So basically, it operates on a potluck model. It's an HPC resource, it's a cloud, there's different ways to look at it. It's one Kubernetes cluster, and it's all operated on a potluck model. So anybody with hardware, they can join it in and federate it and join it to the community so anybody can use it or restrict access to their institute. That's also an option. And like I said, it's all under one Kubernetes cluster. So the provisioning model is all in Kubernetes, which if you're not familiar with Kubernetes, our first training session was dedicated into running directly with Kubernetes through the command line tools that Kubernetes allows. And Kubernetes is a way of orchestrating distributed computing resources. So it's basically a way of knowing how to run containers and on servers and connecting those containers and requesting different resources, like different GPUs, different amounts of memory, CPU at different regions, and that sort of scheduling tactics, running batch jobs, HPC jobs, persistent services, and so on. So since the cluster is Kubernetes, the most native way to run resources is Kubernetes. But for today's session, we're going to be showing you how to use the cluster without having to learn Kubernetes, using the cluster the easy way through services like Jupyter, like Coder, and like our LLM services that we deploy on NRP as well. And the cluster itself has been in operation for multiple years now, and the cluster is called Nautilus. So you see the term here, Nautilus. You'll zoom in. So Nautilus is the name of the cluster. So if you hear NRP or Nautilus, in most cases they're synonyms, because NRP is the platform and it runs a Kubernetes cluster called Nautilus. That said, when a contributor joins in hardware, it has Kubernetes installed, and that's a provisioning model. And other UI stuff like Jupyter Hub and Coder, they run on the top layer. So they're actually still running in Kubernetes, but they're running within their own namespaces, and users don't have to care on how about how that works. So you can just join Jupyter Hub West, and this is what it looks like when you join in. Sorry, let me take off the annotation. So before logging in, this is what Jupyter Hub looks like. So this is the default link, and as soon as I visit it, this is what I see. And I'm sending the link in chat. It's jupyterhub-west.nrp-nautilus.io. So I'm hoping everybody's following along, and you can visit this page and you can click on sign in with authentic. Now, once you hit sign in, you go to authentication, it takes you to say log on, and you can log in, and it'll show your account and email right here. At this point, everybody in this training should be able to follow along to this point, and you should be able to see this page. If it shows you any permission denied, that means you're still not an established NRP user, and you have to go back and watch the first video on how to get access to be able to follow along with this one. But for those of you who are live, you should be able to see the screen right now. And from here, you can request resources. So my Jupyter Hub, in the first training session, we use Jupyter Hub just as a proxy, just as a middleman where we can install kube control and interact with the cluster in a Kubernetes fashion. In this session, we'll do something slightly different. We'll use Jupyter Hub for the resources it allows us to get. So if you look at Jupyter Hub here, first thing is it says /home/Jovian is a persistent volume. What this means is that my home directory, when I start an instance, my home user, they're called Jovian. That's the name of the user. Just like how when you start an Ubuntu container, for example, the home user, the user ID is Ubuntu as well. So Jovian is in this is across Jupyter. The default user is Jovian, and your home directory inside of Jupyter Hub, because that's how we set it up, is it's a persistent volume. Anything you write in your home directory is persistent. It's saved in a volume, and that volume is on a storage pool. It's on a file system. So that volume doesn't care where you get scheduled. So you know how the cluster has multiple servers, and when you schedule here, it schedules you based on availability. So wherever you run, whether you're running in the East Coast, the West Coast, and in Korea and Brazil, your home volume will be attached from somewhere else, from a storage node, and that will be persistent. The thing you write to it will remain. The things you write outside of it, they will be erased once the Kubernetes pod or the Docker container gets erased. So the things you write outside, let's say you install something in Jupyter, it won't persist unless it exists within this one. And by default, it's 5 GB. And that's just the default. That's not a constraint. We can always increase it for users. And it's always better to let us know early on and we can extend it for you rather than fill up the 5 GB because that affects the performance. And Jupyter might crash if you fill up the 5 GB, which we can remediate by extending, but then you won't be able to start it until we fix it. And the storage, the persistent storage is coming from the West storage pool. So these are extra details. You don't have to care about those for now as you get more acquainted with NRP, you can care about storage pools and where they get provisioned from in the file systems. But basically, the storage that is coming from here is coming from the West Coast in the United States, mainly California. And you can always ask us to move you to a different region for different edge use cases that are advanced. And you see here the link available resource page. If you visit it, this lists all the servers, or as Kubernetes calls them, all the nodes that are hosting hardware and provisioning it to NRP. So I'm just going to wait on it to load. and show you the other stuff. GPU types guide shows you a guide about the different types of GPUs that NRP has and the different characteristics like memory each GPU type provides and so on. And the contact admins, this is the most important thing, is that you are on Matrix. So NRP has its own chat server, very similar to Slack. It's called Matrix. And if you visit this link, it shows you all the steps to join Matrix. Once you're in Matrix, you're safe. Anything you need help with, you don't need to understand it from training. You can always go back to us and we can help you. You can message us with any issues that you face and we can help you. So GPU types, you can see this is what the page looks like. Basically lists how much memory each GPU type has and how much of each GPU model the cluster has to offer. And this graph is live. So whenever new resources are added, this graph auto updates. And this is the page I talked about. This lists all the resources. So from here, this is very important. This is where you get insight into what's actually running. So if I go in here and I request RAM to the max, so I keep increasing the counter, and you can see as far as I'm going, it's going with me. And if I go in and request something crazy, let's say I request 2000 gigabytes of RAM, that's 2 terabytes of RAM. I can do so and click the button, but when I look in here and this lists all the servers that I have. So there's a column that says memory total and I can sort it. You can see the top I have is 2.16 terabytes. And of that, there's less than 2 terabytes available. So when I go to do something crazy, it's not gonna schedule for me because this spawner page starts one instance. So it's what's actually starting is one container, and that one container runs on one server. It's not running in parallelism through Jupyter Hub. I need advanced Kubernetes for that, but my instance is starting on one server. So this page is very helpful because it helps me to know what to request. For example, I could be fine with two kinds of GPUs. So I could be indifferent between an A10 and an A100, for example, for some sort of use case. And I can see which one is actually available and schedule based on that. And for my use case here, I'm not gonna do anything crazy. I'm just gonna request 2 cores, 8 gigabytes of RAM, no FPGAs, no GPUs. If you're following along, feel free to request GPUs if you want to test things out, if you want to try out different things. And here it lets me pick images. So you can see there's a doc link here in documentation that shows you the difference in images that we have. But basically, different images come preloaded with different libraries. We always recommend that you use the ones that are noded with NRP first, because those are ones that we built in-house, tailored and customized for NRP. So when you pick the PyTorch image, it has PyTorch customized with the same NVIDIA drivers that we're running in the same versions. And when you pick the PyTorch image, there's actual more dynamic stuff happening behind the scenes. So if I pick the PyTorch image and I'm not requesting GPUs, I pull one image that is customized for CPU optimization. Meanwhile, if I increase this to one, I'll be pulling a different image in reality. I'll be pulling an image that is customized for GPUs and where CUDA and PyTorch and TensorFlow use GPU by default. And sorry, I went back. Architecture here, most nodes on NRP are running x86 64, so uh, there are very rare cases where you would want to run ARM just because there's very few ARM nodes. You can see them here if you look in the resources page. The the ARM nodes have a taint that is saying hardware equals ARM 64. So it's 3 versus more than 500. That's why ideally you would want the AMD 64. And you click start and that starts your instance. So your server is starting up. Now I'm just going to show you the event log just to so we can sort of decrypt what it's trying to tell us. So successfully assigned Jupyter Lab / this long string to this. So Jupyter Lab is just a Kubernetes namespace, just like how each and every one of you is part of at least one namespace. Jupyter itself is running within its own namespace. So my Jupyter instance is running in Jupyter Lab, and this is the name of my pod. Basically, this instance is a pod, and it's scheduled to this node. So this is a node, Suncave 9. And you can see it here. This is the resources page again. So Suncave 9, if I look at it, see how it says CPU 11, 3 out of 16? See how it decreased? That's because I requested two cores. So here, the free is accounting that I scheduled on this node. So I'm taking away some of its resources. And now my instance is running here and I can access it. Now, a lot of this is a little bit of a recap from yesterday, but this left panel here, this is the your home folder. So this is where the 5 GB default that we're talking about is. And if you, let's say I create a file here, so created, and I go to my home computer and I, for example, drag and drop a file here. I also added a file. If I fill up this 5 GB, I won't get more until I extend it. And Jupyter, this is a Jupyter Lab instance. If you're familiar with Jupyter Lab, we've seen this before. You can create notebooks. So if I click this one, it starts a Python notebook. I can just write Python code. And if I go back to the launcher, either from this plus button or from this plus button, I see VS Code. So if I click on VS Code, it shows me a Visual Studio Code instance. Yes, I trust the authors, and this is my Jupyter Hub instance. So these files are mine. Those are in my local Jupyter Hub instance. So if you're coming from yesterday's session, this is the .cube directory we were working in. So this is what we modified here yesterday. And this VS Code is running from the Jupyter instance as well. So since this is a container running Jupyter, it's also a container running VS Code. So the VS Code is a process that is taking some of the CPU and memory that I requested, basically. Likewise, I have a Python shell and I have a terminal. So the terminal, I'm inside a Jupyter container. It's still in Ubuntu OS, so I can run Ubuntu commands. I can apt update. I can apt install. And as you can see, those will go through, but I installed Vim. And then when I go to start later and I need to start a new instance, I will see that Vim is not available. And that's what we talk about with persistent storage, because Vim is being installed in the OS at a different location. You can see it's user share. It's not in user bin. It's not inside of /home/Jovian. So it doesn't persist through restarts. And that's basically how you use Jupyter Hub in a basic fashion. I can name my notebook one, and I can run whatever Python code I want to do in here. So for I5, so sorry, for I range 5, print I, and you can see here I can have my notebooks. This is persistent, so if I close and save, I can reopen it. If I shut down my session, I can still find this notebook because I saved it. And if I shut down my browser window and go back, the session doesn't live in my browser, the session lives in Jupyter. So I can close this. You can see I can add my windows in a different layout. And this layout is persistent. So if I close my browser window and go back, never mind, sorry about that. You need to save it to persist it, but you can still save the layout. And if you close it and go back to it, it will be saved. And one thing to note here is that you can close this, for example, or leave it running and go do something else. Like if I can go to bed and leave my browser like this, come back the next morning, and it will show me a message that says you don't have an instance running, or the instance is no longer running. And that is not an error. So if you leave the session idle and you go back and you find that it was killed, that's because Jupyter Hub has this feature called culling, which deletes idle instances, and that helps us save resources. So when you're running in Jupyter Hub and you leave it idle, you'll see that it automatically shuts down after a while. So that's the basic usage of Jupyter Hub. I'm just going to pause here and ask if anybody has any questions so far, and just to get a gauge of if anybody, if so far all is clear, can everybody just react with a thumbs up if you're able to follow along until this point?
Yes, I do have one question. How you able to check how much persistent volume have you used so far?
So there's command line tools because you're still in a command line environment. So do-sh, this shows you. So I'm in my home directory. So let me show you. This is a Linux Ubuntu thing, not a specific Jupyter Hub thing. So this works for all Ubuntu-based systems and Bash-based systems. But I'm in my home directory. That's what the tilde is. So that's where I'm currently at. So PYD is the working directory. Send the link in chat, which is the directory I'm in. So I need to be in it first, or I can just cd to it. So change directory to it. So home Jovian. And I can just du-sh, and this will show me the storage that is used. So you can see I'm using 327 megabytes of files. If I hit ls, this lists all the non-hidden files and directories. And if I hit ls-a, it lists everything. And uh, I'm remembering this from memory. I could be misremembering, but I think d-h lists each file in its size. That's, of course, the terminal basic way. Since you can connect to VS Code, you can do more things. All right, so far so good.
So my other question, you choose is you gonna have 5 GB by default or you need to request that?
So this is Jupyter Hub West and East. Those are the public instances that we provision for everybody. So this is a Jupyter Hub instance that you can visit the web page now and start one, and it needs a default size. So we set it as 5 GB. So whenever you use it, the default is 5 gigs, but we extend it. That means when a new user comes in, the default is 5 gigs. But once you ping us to extend, it's extended forever. It doesn't re-shrink. It doesn't default back to 5 gigs. It's still extended. That said, the advanced part of the tutorial today is deploying your own Jupyter Hub. So starting your own Jupyter Hub environment. You see how ours is Jupyter Hub-West? Starting your own xyz.nrp-models.io. That is your own customized Jupyter Hub instance that you can be admin of, that you can add your own images to, and that you can spin up for your own user community. So you can get to specify who gets access to it and who doesn't. And that one, you can default it to be 10 gigs, 20 gigs, 100 gigs, depending on the use case. All right. Any questions before we move forward? All right. So the next feature is showing you something in the Jupyter Hub instance that we provide, which is called Jupyter AI. And since I'm seeing a question from Omar, so one thing to note here is that if you start a session here and you see the VS Code link, this is because VS Code is installed in the image. So I'm just going to go to the spawner page again. I'm going to visit the East instance because the two instances are completely separate. So I'm just going to show you the example on here. Oh, my bad. I was testing something on East earlier today and it still hasn't restarted yet. So I'm just going to show you on West again. So I'm just going to stop my server. And this is the spawner page. So I picked the NRP image because for our NRP images, we customize them by installing VS Code into them. So if you pick, these are the default Jupyter Hub images. Those are just Docker images that Jupyter Hub already has. So nothing special that we added in here. So those may not have the VS Code one. And the BData one is another also third-party open ones that we provide. And they have data science tools. So we're just providing these as options, but the ones we maintain ourselves are the NRP ones. So the NRP ones have tools like VS Code, have extra libraries, and have the VS Code button. Actually, I hit too quick. I was going to show you there's a desktop one. The desktop one, if you start it, it starts a full desktop environment. So you have a button that says desktop or no VNC, if I remember. If you click on that one, you will have a full desktop environment inside of Jupyter Hub that is running from your pod. That is extremely useful if you're running something that requires GUI, for example. And let's start our instance again. So the next feature that is also in the NRP images, but not all of them. That's why I keep recommending they use the NRP images because they're customized, they're tailored to have more features, is a little button here that is called Jupyter AI. So Jupyter AI here, this is where it gets really handy. Jupyter AI is a Jupyter extension. It's not something that we invented, but it's something that we add into our images that allows you to use LLMs within Jupyter and this chatbot. So this allows you to connect to LLMs. So when you first started, or if you want to customize your profile, this is what it'll look like on a first start. It's the same thing as hitting this gear icon here. So you can see I can connect Jupyter AI to LLMs. Now, what is the source of those LLMs? If you have an LLM that you have an API access to and you pay for that or you get it from somehow, for example, let's say you're an OpenAI customer and you get access to GPT-4, then you can select GPT-4 and add your own OpenAI API key that you pay for and or have somehow and use that. So in Jupyter AI, you have the ability to pick whatever LLMs you have a mean or like means of accessing them. But the good part here and the cool part here is that NRP provisions LLMs. So you know how we provide CPU, memory, storage, GPU? We have a part of the GPUs, those are taken to the side and used to provision LLMs. So NRP users have access to NRP's LLMs. Of course, all of that is free of charge, all of that is open to the community. So to show you how to access NRP's LLMs, first thing is we're gonna go to the repository that has all the information about today's track. So this is the repository. It's nrp-nautilus/nrp-winter 2026 training, and this is the immediate track. So I'm going to copy this link and paste it in chat. And I'm just going to pause in here just to make sure everybody has opened the notebook. And this is where you can follow along with the material. So every single thing I've said so far is in here. And you can visit back and access it. And now the cool part is that we're gonna be using NRP's LLMs inside of Jupyter Hub. And the way to do so, it's detailed in here. So you can always go back to this text and not what I'm saying, but to know how to access NRP's LLMs, you, and this is listed all in here. So you don't have to worry about how to do so now, but in this page, I'm gonna send this page, NRP's LLM token page. If you visit this page, For some of you, it's gonna say create a new token and list any tokens you might already have. For others, it might say you're not part of an LLM team. That's because to be able to create LLM tokens to use NRP's LLMs with, you have to have your own API key. To be able to generate your own API key from this, you need to be part of what the NRP calls an LLM team. So I'm going to show you how to create a team. So this is my namespaces page. Looks like it's blanking out. Let's refresh. Here we go. So this is my namespaces page. So for you, it's going to show the LLMs, the teams, sorry, the authentic groups and namespaces that you're part of. So for me, it shows me everything. I can see this is my own namespace. And this is the namespace we used yesterday, for example. So mfsada-temp. And if you see here, it's in blue. What blue means is that mfsada-temp is a Kubernetes namespace. So I can use it in Kubernetes with kubectl. The color coding here is a little different. So if it's red, it's just a group. It doesn't exist outside of the website. It's just to make a beautiful tree, to make it organized. So if it's red, it's just an organizing unit here. You can think of it as a folder. If it's blue, it's a group that is a namespace. So blue is a Kubernetes namespace. Yellow is an LLM team. So if you have in this list something that is yellow, it'll show up here and you can create a namespace as part of this. You can create a token as part of this group. So you can see MFSA-SADA-temp-milvus. It shows up in here because I have it in yellow. So this is an LLM team. Also, you can think of it as a namespace admin, who are the users I want them to access LLMs? I put them in this yellow one. I click on it and I add them here in the bottom. Then when I add them in their respective interface, they can see it here, create tokens here. And green, it's a little tricky. So green is both. When I have something that is green, that means if I scroll down, it is both a Kubernetes namespace and an LLM group. That means for the same name, which is MFSADA, when I add users here, they can both use it in Kubernetes and create LLM tokens with it. So for you as a namespace admin, you have a namespace, it's in blue. You have the ability to go to scroll all the way down to create subgroup. And I hope you're following along. This is the namespaces page. Uh, Create subgroup after you click on your namespace, and you can see here I'm editing my namespace. I create subgroup, and the subgroup I want it to be an LLM group, and I want to give it a descriptive name. So MFSADA LLM group tutorial, and I create this, and this was created. Now I can go back in here and refresh my page, and for groups, you can see it right at the top, and that means if I add, let's say, here's my group that I created. So you can see it here, it's in yellow because it's an LLM group. I can click on it and I can add Daniel, for example. You can see here how to add users. Just waiting on the search. And I can add Daniel. And now from Daniel's interface, when he goes to the page, he can see the LLM. He can see the LLM group, sorry. Now when we go in here, now both Daniel and I can see this. If I remove myself, go to refresh. Let's just wait on it to load. I no longer see it. So you as a namespace admin in your own tree, you get to select who gets LLM access. And now I'm going to use this other group just for the sake of demonstration. I'm going to call it my key for tutorial Thursday. And you can see there's two buttons. One that says create new token for general LLM API access. And this is the general button that It allows you to use different applications. So this is an API standard. And this one is for something called Chatbox. Not gonna get too deep into what Chatbox is, but basically Chatbox is an application. So I have it on my phone. Many users run it. You can get the Chatbox config if you use that specific application. But this is the generic method that a lot of applications use. And I can just click on this. And temporarily, so all of you can follow along this tutorial, I'm going to copy this token and paste it in chat. So you can follow along with this and test things with this. But after the duration of the tutorial, this token will be invalidated and you will have to provide your own token through the same steps that we did and use that token instead. So this token is all you need to access NRP's LLMs. And it doesn't have to be in a pod. You can put this token on your phone. You can put this token on a different app, on an end application, and you'll be able to access NRP's LLMs. Now, in NRP's documentation, so NRP's documentation, we always keep this page up to date. So this is documentation. If you go to LLM, AI LLMs, NRP managed LLMs, and I'm sending this in chat as well. This page is always up to date with what LLMs we have. For now, I'm just pasting because we're going into Q&A in a little break in a minute. I just pasted the token in here. Once we come back, I'll show you how where to put this API token and what to actually do to be able to use the LLMs. But for now, all you care about is being able to create LLM groups and generate keys inside of these groups. And as you can see, you can have multiple. And just saying this, so multiple doesn't mean multiple, multiple generating multiple doesn't mean more use. You still you still are able to use what is available, but generating multiple means you can monitor the usage of different keys. So this is internally for your own organizing. You can set them to different teams. And the page I sent, you can always see here up-to-date models on what models are available. And we code them. So main is, you can think of main as long-term support, and evaluating, that means we're just evaluating a model. We're testing it out. So GPT OSS, we're evaluating it. If it's a good model, a solid model, stable, has good results, we'll keep it. If it's not, we'll take it out, put something else in, and so on. And we're at the 45-minute mark. I'm gonna pause here. I'm gonna pause recording so you can ask freely and recording. All right. For the recording's sake, welcome back everybody from the break. I'm just showing starting a new instance. So if you're inside of Jupyter Hub and you want to start a new instance, all you have to do is click File and Hub Control Panel and stop the old one and start a new one. So you can see here I have stop and my server. If I click stop, I can start a new one and I can pick the image I want. Right now I'm running an NRP desktop image and I'm just waiting on it to start.
Why you running NRP desktop? That's a different option.
Just to show you the desktop environment.
Oh, gotcha. Okay, thank you.
So it's just to show you one extra feature that this image has as opposed to others to see it in action. But you can choose whatever image you're comfortable with. As long as you're using the NRP ones, they have the Jupyter AI features. And it's good that we're seeing these. If you see messages like this, these are just it taking too long and not the messages that are alarming. Just means wait on it a little bit and it will start in a minute or so. So here what's happening is my pod got assigned to a node in Korea and my volume lives in the West region. So my volume is in California and my pod is in Korea. So I'm just gonna wait on it a little bit. And I can see some of you are also starting your instances. They're also pulling. And while we wait for it, just make sure you have the notebook. It shows you different details. So I'm just going to go over them while this loads. So part one in the notebook, sending the link in chat again. You can use the same instance you've used before. The only reason I stopped it and started a new one is just to show you how to stop in case you want to change an image and in case you want to pull a new one, and just to show you the desktop one. And now the notebook here, part one is discussing what the NRP's LLMs have to offer because we have different applications as well. So Libra Chat is a chat client. So Libra Chat, NRP's Libra Chat is it's linked, it's an end client. So you can see it's a chatbot. I can just log in the same way I log in to everything else. And I can just directly start chatting, similar to how I do with ChatGPT, for example. And I log in. You can see here, I can chat with how to write a Sudoku solver in Python. This is just a chatbot interface. So I can pick what the LLM is going through here. And it'll go through. Likewise, I can do the same from Jupyter Hub. And looks like it's taking a little bit with GLM-V, but here's the answer. You can see the output also heavily relies on what LLM you're using. So this is the quality of the output is based on the model, and you can see different characteristics from NRP's documentation. Now I see a question, do you offer something similar to what you are doing for LLM, but for running custom PyTorch models? So the LLMs, it's just an API. So we're saying what LLMs we're hosting from GPUs, but those are the ones we host. Those aren't the ones we say you have to run. My Jupyter Hub environment, in here, I can request GPUs. And once I request GPUs, I'm in an environment that has access to GPUs and has PyTorch uh, installed and ready. So I can just pull my PyTorch model and pull a notebook that runs the model and run my own model on GPUs. The consideration here is that when you run your own LLMs as opposed to using our inference services, that there's so many users and a limited pool of GPUs, so there's consideration towards not idling resources. But as long as they're in use, and we see this with a lot of research, there's a lot of research that is depending on LLMs today. We see a lot of users and groups spinning up their own LLMs as well. And let me see what's happening with my instance. Doesn't look like it's too happy. Okay, let me just give it a kick from the back end so we don't have to wait forever. And you can see here examples that are using the LLMs directly. So while we wait, I'm going to show you this from the terminal directly. So this is my terminal. I'm just going to increase the font so you can see it. This is the command. So curl, if you have curl installed locally, you can run this here. You can see here it listed all the models, even though I didn't replace your token with my token. Just because listing the model is not something that needs to be secured. Anybody can list the models. In fact, the link here, you can visit it in a browser and list you the models. So here are the models that we host. But the correct way is to replace your token with my token. So we sent it in chat, the exact same one. Let me find it again. There we go. Send it in chat again. So this is my token. So if I go back to the exact same one and paste my exact token in here, this goes through. and it lists them. I can do something more elaborate and actually ask, for example, GPT-OSS, how do I check if a Python object is an instance of a class? So if I use this as is without replacing it, it's not too happy. But if I actually go back to my token, sorry, let's copy it. Try again. If I go back to my token and replace it with my actual token and just give it some time to, because it's talking to the LLMs, generating the response. So just gonna give it some time and wait for its answer. So you can see here, this is its entire answer. So true in the object, you can see it is responding text. This response is an API response. It's JSON. It's messy to dissect as a human being, as a human reading it. But this is the response applications expect. So Jupyter AI is an example of an application that is expecting something similar. So I'm gonna show it to you in Jupyter AI. Just 1 second. Looks like in starting and stopping too much, I upset my instance. It's taking a minute to load. I'm looking at it. Sorry about that. Let me just give it a kick. All right, we can resume in Jupyter Hub and start a new instance. All right, should be faster now. Let me just show you. And we'll wait on it to start. Now we're going to use the exact same LLM token, but to talk to Jupyter LLMs. And let's see. Please don't fail us. Don't let us down. Give it a minute to load the instance. All right. Sorry about that. It's the demo effect. Things always have to not work from the first try, but we do need Jupyter Hub to show you how to use Jupyter AI. So I'm just waiting on it to start. How's everybody doing? Do you guys have Jupyter AI and are you able to access Jupyter AI? So this isn't happening because it shut down because I was using it. It actually happened because I stopped it intentionally. Sometimes things do take a while, especially if there's like heavy use, but it usually resolves on its own. So you can see here, it did take a while, but eventually it finished with attaching the volume. Now it's pulling the image. So hopefully it will be a little faster this time around. So once you see attachment successful and you start seeing pulling image, that means it attached the storage. So that's a good sign, which means it's right now pulling from the registry. And with this new Jupyter instance, I don't see the button. Which large language model to use? That's basically a preference thing. I like Gemma 3 is nice. GLM is pretty advanced, but it's all based on preference. And I don't, I'm, I'm looking, I could be mistaken, to be honest. I think the desktop one might not have Jupyter AI, but the PyTorch ones might do. So just waiting on it to start. But okay, now, okay, East is back. We can parallelize to reduce downtime. So you can also use Jupyter Hub East. I'm starting the desktop one, but let me start another instance that is using the PyTorch image on East. So those two instances are completely separate Jupyter Hub instances. So they're not connected in any way. If you modify one, it doesn't affect the other. And I'm gonna give it some time. The desktop one, when it says started container and it's starting off at the last second, it might take a little longer just because it has a full desktop environment to set up. And so directories and VNC access and so on. And this is the PyTorch one on East. So I'm starting two instances in parallel just to reduce downtime and see which one starts first. Okay, so this is East on the PyTorch image. You can see here, this is Jupyter AI. Perfect. So this is what it looks like on a first visit. Welcome to Jupyter AI. I'm visiting it for the first time. Start here. Okay, we'll visit that one later once it starts. But for now, let's focus on this one and start here. This is what it looks like on a first visit. And completion model, this is what I care about. You can see here, there's a lot of options here. The one that you care about is the OpenAI general interface. So those are different platforms. We don't care about them. We're not going to be spending any money. We're not going to be connecting to anything commercial. We're going to be using the OpenAI general interface. This is what I meant when I said it uses the OpenAI API, because this is not going through OpenAI. This is going through the provisional model of OpenAI's, uh, basically OpenAI's API specification. And please feel free to unmute and ask.
I had a question. I was also my server is starting up, but how can I stop the serving? Because it's try to open a new instance, but it's still open what I was trying to open. Um,
So, oh, let me
like I
go.
choose a desktop also, but I want to change it to choose PyTorch. But it's like it's keep. it's not going back.
Just in one. So I just stopped it for you. It will reflect in 1 minute and you can start another one. Let me see.
uh,
Things will reflect in a minute. It just needs a little bit of a while. Manage.
okay, now I'm okay.
Perfect.
Yeah,
All
yeah.
right. Can everybody see this? I mean, I know, Jan, you're starting your instance now, but for everybody else, can you see your instance now? Can you see this Jupyter AI side panel here if you visit this?
Yes,
Oh, perfect.
yeah, we can see it's opening lines.
Chris, can you try to start an instance now just to see if
Yes, okay, I think it's working.
so Chris, I see your instance now. I'm assuming it is happy now. I see it running.
Yeah, I'm okay now. Thank you.
Oh, perfect. All right, so please let us know if you're not seeing this window here at this point. And because this is better if you follow along live, then you can set it up once and not worry about it. So please let us know if it's not happy yet. But I'm assuming everybody here, everybody viewing this is caught up and has the screen. If you've used Jupyter AI before and you want to set it up again, it's the same gear icon. So this is the window that we're resetting. Completion model, like we said, it's the OpenAI general interface. Model ID is the model I'm going to be using. Let's skip that one for now and go to the base API. So the base API from our docs, you can see here API access. This is our endpoint. So OpenAI general interface is just an API standard. Anybody can use it. The endpoint you're connecting to is NRP's endpoint, which is this one here. So I'm sending it a chat. So API endpoint here. And token is personal. And for different applications, they have different naming conventions. But Jupyter AI, for Jupyter AI, the completion model is OpenAI general interface. If you're going to be using an IDE or something, different applications use different namings, but it's always used called OpenAI or OpenAI general interface or OpenAI compatible endpoint or custom OpenAI endpoint. And it always asks for a base API URL, which is this with the V1. And model ID, for my case, of course, the models, like we said, we always host them live from NRP's documentation, what the models we're hosting. So this is NRP's website. I can click docs, or I can send you the link for documentation. And NRP managed LLMs, and this is the live list of models. So these are the names you're going to be using. So I'm going to be using GLM-4.7 for to demonstrate, and this is our window. I'm going to use this as my model ID, sorry. And like we said, we're going to use this as our endpoint. And now we have one, two, three fields that are consistent. And lastly, the API key. So the API key, ideally, all of you would have your own API key right now during this call because you all can create your own LLM groups and use your own API key. If you don't have one and don't want to like not catch up to the training, here's a temporary one. I sent it in chat and I'm going to paste it here. This is the same one I sent in chat. You can paste it in here and save changes. I'm gonna save it. I'm just gonna hit save changes. And now I can go back and I can talk to the chatbot. So you can use this token, but it will eventually expire because we're just using it for the sake of testing it out. And I can just here ask how to know if an object is an instance of a class in Python. And this is going through the same model I specified, which is GLM-4.7. And we're going to give it some time to answer. I don't know. Very verbose. Of course, here you can see the quality of the answer depends on what LLM you're using. I'm gonna show you how to edit. So let's say I stopped my instance, I started a new one, you will see that the information is saved. So I don't have to put in token every time, the information is saved. Let's say I visit it again and here, and I want to change my key or change my model. This one is Jupyter AI. This is what it looks like. I go to the gear icon, and this is very important because this interface is a little tricky. So let's say I want to switch out to Gemma 3. You can see it already re-erased my endpoint, so I have to paste it again. And my API key is saved. It's just blanked out. But if I want to modify it, what I do is I hit the edit button. This allows me to paste a new one. And you can see this is the same one I sent in chat. And this is the tricky part is if I hit this, it didn't save it. You have to double click it. And then when you see API key updated successfully, that means it's taking the new one. Then you can hit save changes and let's see if Gemma 3 is nicer to us and more willing to help. And you can see ask is from learned data and that add file is from files that we have. So it doesn't need to, it might not know how to answer based on the data that we have, but we can always ask it without the ask. So you have to click the check button, the green one, double click it. So click it twice in a row, and then it will allow you to save. You can see if I ask without the forward slash ask, it might be nicer. Let's see what happens. All right. Looks like a good sign because taking a while means it's generating an answer in most cases. So you can see if I don't add that forward slash ask, it doesn't answer from the learned data, it answers from the general knowledge. So these commands are very helpful because I'm going to show you a very helpful one, the forward slash generate. I really like this one. And I'm just going to let it run in the background. Generate a Python notebook about a Sudoku solver with test cases. And you can see it says it's going to be working in the background. So I can just ignore it for now and it'll let me know when it finishes. I'm going to do something different. I'm going to open new and notebook and I'm going to create a Python notebook. So file, new notebook, and here's my notebook. And I'm printing. This is Python. If you don't know Python, you don't have to worry. We need cases where we don't know how to do stuff to see if the LLMs are helpful. You can see I printed hello without closing hello. Actually, let me forget the T in print. So I try to run it, it gives me an error. If I select the cell and run back to the chatbot and I just say forward slash fix, and that's all I say, it knows that I'm talking about the cell that I pointed to. So I'll just wait on it. You can see this is the fix it gave me, and it has different options: insert above, insert below, or replace or copy. So I can just say replace and voila. I can do something different, like for I in 5 and I should say in range 5 because 5 is not iterable. Let's see if it knows how to fix this. And give it some time. All right, and it knew how to fix it. Let me try the insert below. Let's see, here's the answer. And one thing to show quickly, if you try to save the API key and you go to the gear icon uh, and you hit edit, and let me show you again. So if you copy and paste the key, see the key here, and I hit save twice, it doesn't show it again here, but it says API key updated successfully. If you're visiting Jupyter AI for the first time and you're trying to add it the first time, it's just a single click or just typing it in and clicking save changes and that's it. But if you're adding it again, you need to double click the check button. And this is pretty much it. We're still waiting on this. Looks like it's still churning up, so we'll get back to it, see if it does good. And to show you the other stuff. So this is our notebook. These are Python examples, curl examples, available models. This is all covered using Jupyter Hub. So far, we've all used Jupyter Hub. We have another service that I'm not going to spend a lot of time on because there's a big overlap with what Jupyter Hub does, but it's another service that you have the option to use, which is Coder. And NRP's Coder. I sent the link in here in chat. It's coder.nrp-nautilus.io. You can see nrp-nautilus.io is NRP's domain, and the services we provision are normally the service name.nrp-nautilus.io. And and so you just to answer a quick question in the chat, to be able to use fix, you need to run it and it shows an error, and then you can ask it to fix. So I ran this, it showed me an error, then I can select this and type in fix. So this is another service called Coder. I sent it in chat, and you can sign in with Authentic, which is our authentication platform, very similar to how you signed in with Authentic to Jupyter Hub. Of course, this is its own instance, so it doesn't see your Jupyter Hub instance and vice versa. I'm just gonna log in here and pause and see if anybody's caught up with Jupyter AI and if you're having success with it. Uh, Please let us know. Okay, just looking at chat, seeing if anybody is having a good experience with Jupyter AI. Has anybody been able to use it successfully?
I got errors when I put the commands there in the prompt, uh, but
So,
I'm typing the wrong commands. So how you put a code? You just put the code there in the chat box.
so the code you mean to
I
fix?
need to open first a notebook, right?
Yeah,
And
so
okay.
so sorry, I'm just not getting your question. Is your issue not able to like is the chatbot giving you error messages on the left here or
Yeah, so I got errors, but maybe it's because I'm not putting the right thing.
So just to briefly go over it again, if you hit the gear icon here, you have this as OpenAI general interface, and this is the exact same link. And I'm assuming you're following with this, right? You have
I'm
this.
sorry. No, yes, I got that part already. I'm already in the chat. I already put the API keys. The chat is open, but I put all the code and it give me errors. It's like it's not working, the chat box.
So if you can post your error message in chat, we can.
Yes.
Yeah, perfect.
I'm gonna close it here.
Right.
I try to,
Oh, so generate is as a command. So generate generates an entire notebook. This is what we tried in here. You can see it's been 7 minutes and it's still running. So some models are faster than others. Some if it takes a very long time, some models might still time out with the API call and trying to generate an entire notebook. So it could be very specific to generate. A quick test is just to not ask generate, just ask what time is it, and it's not going to web search for what time. It's probably going to say I don't know, but as long as it responds with text and not an error message, then you can find out if it authenticated or not.
yeah, when I say what time it says, it will give me a error. It's a, I can show you the error. Um,
All right, so just for the sake of time, let me just show Coder here before we go jump into Q&A, and then I
uh,
can help you with the error through in the Q&A session. So this is Coder. I sent the link in chat. It's another service that I want to show everybody. So Coder is another web service. You can see here the interface also similar to Jupyter Hub allows you to start up instances. So you can see I see workspaces and templates, which are what I care about. So workspace is you can think of it as an instance of your own server again. So new workspace, I can see all templates. These are all the templates. So similar to how Jupyter Hub has pickers for GPU and whatnot, Coder has templates. So one template, a very wide use case for Coder is to use FPGAs because we have a very elaborate setup with all the SDKs and IDEs and whatnot for FPGAs inside of Coder. But basically, let me show you something simpler, which is just using the general template, which allows me to do multiple stuff. I just click on it and create workspace. And the workspace name has to be unique for me, and the coder does suggest random names. So I'm just gonna use Blue Cat Shark 84, for example. And parameters, you can see this is very similar to what Jupyter Hub has. So I can pick region, how many CPU cores, how much memory, if I need a GPU. Node picker, this is optional. I can just say any, and different images. So the CUDA one has PyTorch and CUDA and whatnot. The Ubuntu one is just plain Ubuntu. This one has a desktop, no FPGAs, and I can just click create workspace and just wait on it to start. So one advantage in using Coder over Jupyter Hub, even though they do very similar things, is that I'm starting Blue Cat Shark 84, can run back to workspaces and start a new one. So it's another way of running parallel setups without having to learn Kubernetes and learn kube control and whatnot. Can just start Azure Dolphin, let me say 1 CPU core, 2 gigs of memory, and start it. And I can run back to my workspaces. You can see I have a long list, but let's search for my CatchArk one. You can see it's starting. And Azure Dolphin is also starting. And you can see in the logs, if you try to sort of understand what it's doing in the logs, you can see it's actually creating a Kubernetes pod. Because like we said in the beginner track, every single thing you run within Kubernetes, it's running within a pod. So a pod is a single instance of one or more containers. So everything you run is a pod. Storage is a volume, and the rest is just glue between the containers and the storage. So when you run a job, it runs pods under the hood. When you run a deployment, it runs a pod under the hood, and so on. And we'll just give it some time because it's also creating a persistent volume for this pod, and it's starting it. And here we go. Let me give it some time to hold the image. In the meantime, while this starts, we'll jump back to Jupyter Hub. Uh, let's run back. So you can see I asked it to generate a Python notebook. It says, great, I will get started on it. That was at 3:30 my time, which is Eastern. 3:38, which is 8 minutes later, it says, I have created your notebook. So if you use generate and have seen silence so far, eventually uh, as long as you're seeing silence, it's going through. If you see an error, it will show you the error. And if you don't, that means it's still going. Eventually, you will say success or end up failing for any reason. But in our case, it says backtracking in AC3. You can see here, of course, I hope it all runs, but so far so good. If anything fails, we can always ask it to debug itself because we have the fix command. You can see testing easy puzzle and looks like it solved it correctly. So that's pretty impressive. I'd say it's worth the the 8 minute wait for the results we're getting. As long as I'm not checking the code, I hope it's not hard coding answers in. Let's try hard ones. Wow. And yeah, hopefully you had a similar experience. Now we can jump back to this one and blue cat chart. You can see apply completed, apply complete, and it's starting up. So one thing to note here, the buttons you see here are based on what template you're using. So the template I'm using is Ubuntu without a desktop environment. So VNC desktop initializing that might not go through depending on whether or not the image itself has a desktop. Uh, the one thing you will always see in every workspace you start with encoder is VS Code Desktop, Code Server, and Terminal. And I see one question in chat. It says your workspace is running, but one agent is unhealthy. Uh, we've seen two scenarios. One of them is there's an issue with the underlying node, so the host server, and you can restart and it resolves. And the other issues might be just a false positive, and the agent just needs some few seconds. So if you still see the issue, you can restart your workspace, and it will reschedule somewhere else, and it should all be happy. But like I said, with every workspace, so feel free to restart and I'll take a look at it, see if it's happy. And other than that, you can see those three buttons. So terminal, this is terminal inside a browser window. So this is a web service terminal kind of that is running inside my browser window, and this is running from my instance. So if I look at free-h and I look at the memory, it's grabbing those numbers from the underlying node. It's running from the Kubernetes. So this is the Kubernetes pod. Had I requested GPUs, I would have been able to look at them with the NVIDIA SMI, for example, or run CUDA if I requested a CUDA image. And I can run whatever I want in here. This is Ubuntu based as well because we have an Ubuntu system. Let's see here. So that's terminal. Code-server. This is similar to what you saw in Jupyter Hub. It's VS Code running directly from my instance. So you can see this is from my instance. If I open an integrated terminal and I look at, for example, date, this time is pulled from my machine that is running the pod and not from my local computer. So I can run super user sudo apt update. It's the exact same command I ran there. And it's updating my Ubuntu packages. This is not running in my local VS Code. This is running remotely. Because I'll show you. This is my local terminal. And I'm on Mac. I can't run this command. So this is actually running. The entire IDE is running from your workspace, from the remote pod. Which means if you have VS Code extensions that you installed, you won't see them here because the extensions here are for this instance. So you can see even the basic Python one. It's not installed. I have to install it. Once I install it, it's installed in my own instance. But this is not related to your local VS Code. So this is my local computer. I have VS Code installed. I might have this customized. I might have the extensions here. This, when I open it, you can see this instance is different from this instance. The extensions I have in here are different because this is mine, this is remote. Which is why this is important because this connects the remote instance to my local one through a custom extension that the developers of Coder have developed. So when I click this, it takes me to mine, allow Coder to open this URI, and you can see now this is remote. This is opening a tunnel, and this is connecting my local VS Code with my remote instance. This is very important for vibe coding and any extensions that you might have already set up and you want to use with your coder instance. Just hit the button and it starts. You can see it's all going through SSH and just giving it some time because this is a fresh VS Code, so it doesn't have the extension. So first time around, it installs it from scratch. You can see here, open folder, /home/coder, because that's the name of the coder user. So this is remote. I create a new file and call it trust folder and continue. If you create a new file and let's wait for it to connect. This new file doesn't exist anywhere in my local computer, but it exists in the pod, the workspace. So we can see I can list and here's new file. And this is pretty much it. And sorry, we ran over time. I'm gonna pause here. I'm gonna pause the recording and answer. All right, now for this last exciting part, we're gonna be uh, converging what we learned so far in this session and in the previous session, and using the Kubernetes bits that we learned into deploying our own Jupyter Hub environment. And likewise, you can follow very similar steps that we reference in our documentation to deploy your own coder. So you can deploy your own coder environment as well for your own users and customize that as well. But for the sake of this session, we're going to be showing you Jupyter Hub and spinning up your own Jupyter Hub. So let me clear out my annotations. So this is Jupyter Hub West. You've seen this interface before. I'm just going to start a session in it that we'll be using as the environment where we're going to be using Kubernetes. So last session, we used the Jupyter Hub to spin up kube control. Now, whatever environment you have kube control set up, you can use for the sake of training, for the sake of following this part. So this is my local terminal. I have kube control set up here. I can test by listing pods in my namespaces. I can use this, or I can use Jupyter Hub. And if you followed along the steps for the previous session and kube control worked for you, you don't have to worry about going through the exact same process. We've consolidated it into a single command that you can run and reinstall kube control if it's a new session. So basically, this is the notebook. I'll reference it again. So the tutorial notebook. And part three is using Coder, now deploying our own Jupyter Hub. So this command, and this was just the last night edition. I'm going to be testing it on the go with everybody, see if it goes in happily. And if it goes through, looks like I'm not having good luck in spinning up fast instances today. So we're just going to give it a minute to load. So in the meantime, please make sure you have your Jupyter Hub instance, whether on West or East, it doesn't matter, but please make sure you have your Jupyter Hub instance up and running. And trying to rush my instance here. So installing Cube Control in Windows is very tricky. If you don't have it happy, it's gonna take some steps to install it. But in general, I'm gonna give you the link for the National Research Platform's YouTube videos. I'm pulling them up. So you don't have to worry about this for now. You can just spin up a Jupyter Hub West image and use Cube Control there. But after the training is done and after the session is done, you can test this out here. I'm just gonna send the link in chat. So this video shows you step by step on how to install on Windows because the authentication step needs a couple of extra steps on Windows, so you'll be able to follow along. But right now you can follow along with Jupyter Hub West. My instance is starting now. I'm gonna give it a minute. And 1 second. All right, just 1 second. All right, so this is our Jupyter Hub, and this is our notebook. I'm gonna copy and paste this command and hope for the best. I'm gonna hit enter and wait for it to install. So I'm just gonna, for the sake of simplicity, I'm gonna have them side by side. Gonna close this. So this is from GitHub, and you have the link in chat. So let me send it again, the tutorial notebook. This is what's on the right side in here. So intermediate track training.md. And on my left side is my Jupyter Hub West. So The way I have them open in Chrome is this extension that I have is called Side Space. If you're curious about this. But basically, here's my notebook and here's my Jupyter Hub terminal. So I'm opening a terminal window. All the other parts we've done, now we're in part for deploying Jupyter Hub. So the first step is to install kube control and kube login and do all the steps that we've done yesterday. If I paste this command in and I hit return and I wait for it to download and install Homebrew, your output might be slightly different based on whether or not you have Homebrew installed and kube control installed from different starts, but this should handle everything. And if you wait on it a little bit, it says installation successful, and I'm still running stuff in the background. I'll wait on it a little bit. And okay, looks like, sorry, there was one step that we forgot, which is, let's go back again. Okay, so one step that we forgot, sorry about that. Let's do it all together. So first step is wget nrp.ai/config and move and make your dash b. I'll send the comments and the commands in chat. I'm just testing them here. And move. And now let's run this again and test it out. Return, and let's give this a shot. And just to answer, the site space extension is just a browser extension that allows me to open the two different pages in the side view like this. So you can see I have separate views. I can reverse them back. All right, it went through. So I'm gonna send everybody the commands in chat. So the commands to run. Let's run back. So first one is wget. And once you run wget, this will download the config file. And the second command is making the .cube directory. And this last command is move config to .cube /config. And then you can run this whole thing. I copied it and pasted it in chat. This will ask you to hit enter to install Homebrew. So make sure you hit enter and or return, and that will install it. I'm gonna go over the steps again with you. So this is the clean slate now. The commands we pasted in chat. So first one is wget. So copy, paste, hit enter. You could see it downloaded a file called config in the local directory I'm in. And it's this one. So you can see the file in here. That's the first step. Second step, I create the .cube directory, and -p basically tells it if it exists, that's fine. If it doesn't exist, create it. And I shouldn't see any output. It just creates the directory without telling me anything. And then lastly, I can move the config file from the local directory where I have it to .cube and call it .config and call it config. And now lastly, this whole giant block that I sent in chat, and it's the same one in the notebook in here, if you copy and paste it, this asks you to install brew or homebrew, and if you hit enter, it installs homebrew, it installs kube control, It installs kube login. It does modifications to the config file so it works well for us. And last step here, it attempts to authenticate. So it gives me a link to open. If you're doing this, see, please visit the following URL in your browser. So if I click on this in a browser where I'm authenticated with the same identity provider that I use with NRP, it says you may close this page now. So I close this and you can see this will be happy, hopefully, fingers crossed. And you can see if it's happy or not because this command will list the top 5 nodes in my cluster alphabetically. So if you see this output, it's all happy for you. And this should work on Jupyter Hub West and setting you up and running. Now the next command is that if I run brew, you might see a command that says brew not found. This is because you have to do something called sourcing the bash profile again. So if you see brew not found when you attempt to run brew again, you can just run this second command. Sorry about that. This is authenticating. Let's see. So when you see this, just copy and paste. If you see something that says no, if you see something that says this file doesn't exist, don't be alarmed. You can still just run bash and then you can run brew. Oh, never mind. Sorry about that. Let's give you the eval command. So these are the commands. If you scroll up, next steps, if like my environment, your environment is still not happy, you can just copy these and paste these. So from here, just gonna copy them and paste them in chat as well. So if you see the message in the comments where it lists the nodes, then it's all happy. And if Homebrew is taking some time, that's perfectly fine. That means it's just installing under the hood. So just give it some time. And then after this, you can just run brew. If you can run brew, that's perfectly fine. That means you can proceed to the next step. So I'm just gonna pause here until you can run brew and you can list stuff and you can run kube control get nodes and it can list stuff and both are happy. So just to make sure everybody's at this step before we move forward, can you react with thumbs up, some thumbs down? So
I you say to I type brew, but it's say command of
so you ran the same commands I sent in chat. The
yes, I run everything and I got the ready status for the four
Yeah. So,
files.
so you need this to run this code block that I just sent.
Oh, this is used now? Okay.
And
Then brew. Okay, now it's okay. Thank you.
And for the error with the get token, that means something is not happy. Did you run the same command blocks? The wget, make dir, move, and then the big block? If you want, I can take a look from my end. Just gotta make sure everybody has kube control happy because once you have kube control happy, you can carry on with the other steps. But if you don't have it happy at this point, it's gonna sort of pile up. All right. Kamalika, I'm looking at your instance now, trying attempting to fix it. Everybody else, I'm assuming your instance is happy.
Mean happy.
You can run kube control get nodes, you can run brew, and both are happy.
Um, Python.
So to test it out, you can just run kube control, get nodes. And this should list nodes. It should be a lot of lines, more than 500 nodes. So it should be something, see something similar to what I just pasted. Pasting the link, pasting the command. If you got a 500 internal server error, if you refresh, it will go away. The reason is because the Jupyter Hub pod is a pod itself. So if anything evicts it or disrupts it, it starts a new one. So you might see some refresh period there. And there we go. All right. Looks like all is well, Kamalika. I think your instance is happy now. I'm testing it. Mhm. All right, it's happy now. Once you try Cube Control Get Nodes, it will give you a login link, and you can visit that, and it will log in correctly. All right, so that means everybody can proceed to the next steps. The next steps are in here. So first, ensure Helm is installed on your system. So if you're running Jupyter Hub, you're going to paste this and it's going to say Helm command not found because we haven't installed it yet. So that's perfectly fine. It's perfectly natural. What we're going to do is, since we have brew running, we're going to copy this link, this command, brew install Helm. It says Mac OS, but since we have brew installed on our Linux, this works and this works. And we can just brew install Helm and it will be happy in a minute or so. And I can test with Helm version now, and you can see it gave me the version of Helm that I'm running. Showing you this again, so copy, paste. And now section 4.0, 4.2 is running this Helm repo add. And so to explain what's happening, Helm is sort of a Kubernetes package manager. So there are multiple steps to installing Jupyter Hub that if we were to give you YAML files, you would be installing multiple components, taking a long time and going through a lot of steps to install it. So Helm does that level of automation. You can think of it as a package manager. You can tell it I want Jupyter Hub and it does all the necessary steps. So Helm has repos. You can add Jupyter Hub with this link and then it will know what Jupyter Hub is from this link through what is called a Helm chart, which is basically a recipe towards what needs to be installed. And once I add a repo, I just do Helm repo update. It says update complete, happy helming. Then Helm repo list, this command right here, it should at least list Jupyter Hub. If you've used Helm before and it lists other stuff, that's perfectly fine, but it should at least list Jupyter Hub. And now if I see this, that means I can deploy Jupyter Hub. I need both Helm installed like I need the Jupyter Hub repo, and I need to be a namespace admin. So far, anybody can do these up to this point, but if you're not a namespace admin, you will see failure in the next steps. The next steps. So this is a Jupyter Hub config file. So the link to the full documentation is here. You can go over the information inside of it and create your own Jupyter Hub. For now, we've given you this simple example that you can follow. So I'm just going to show you this example. I'm going to copy the whole thing. I'm going to go back to Jupyter Hub, to the File Explorer panel, and I'm going to create a new file here. Right click, new file, and I can call it whatever I want. So I'm going to call it values.yaml for me, and I'm going to open it. And it opened. It's just a new file that I created uh, with the YAML extension, and I can just copy over the entire long thing in here and just paste it in here. And we'll go over the sections in here after we run it. I'm just gonna run it and show you what happens first. So this is the YAML. I'm gonna scroll down, generate secret token. See OpenSSL, rand hex. If OpenSSL is not installed and you don't see a random token, that's perfectly fine. But you need this random string, and it doesn't have to be from this command. You need any secure random string, and you're going to copy this over with the OpenSSL command. So this is the step here. You're going to copy this over and go back to the values.yaml, and you're going to paste it in the proxy secret. So let me look for the section. See hub, inside hub, I have config, service, whatnot. That's for hub. For proxy, I have a secret token. So I'm gonna place this here. And the reason you need sort of a password or a token here is because if you don't, and if it's something insecure, the way to look at it is that any other pod can infiltrate itself and act as a Jupyter Hub pod. So when you have a secret token, then Jupyter can authenticate its own pods. So the main command center that is provisioning Jupyter hubs for users, so the hub, sorry, that is provisioning Jupyter labs for users, the hub itself, it can authenticate which pod in the namespace is its and which is not its own, it's something else. So it doesn't, even if you don't know what this is, that's just fine. All you need to know is that you need to generate a new secret token and place it here in secret token. And the next step is I have this file. I can just go over and apply it. And the command to do so is a Helm command. So this is the command in here. I'm going to copy and paste it. This is the command. Don't apply it just yet. I'm just going to show you a few things. So there is Helm install and there's Helm upgrade. You can run upgrade even if you don't have it installed. And that means install if not available, upgrade if available. Cleanup on fail, that means if it fails, it doesn't leave remnants, it cleans up itself. Dash dash install allows it to install if it's not existent, but if it exists, just upgrade. Release name is a personal name, or not personal name, but it's customizable name. It's the Helm chart release unique name. So if it's my Jupyter Hub, that's fine. As long as it's unique per your namespace. So my Jupyter Hub is fine. Jupyter Hub is fine. JH is fine. Again, this is in your own namespace, so the release name only matters to you, basically. And this is where the repo is. So Jupyter Hub / Jupyter Hub, you don't change this one. Namespace, this is where you change it. So this needs to be a namespace where you are admin of, and this needs to not be a namespace where you already have a Jupyter Hub. So this is what I mean. So if I go to namespaces, it lists my namespaces, right? And some of you might already be in namespaces that do have Jupyter Hub. So for me, I'm gonna show you. So let me open a new terminal. So let me source my bash again in the new terminal. So you can see this is my namespace. This is my personal namespace that I use for my projects. You can see those hub and proxy pods. Those are Jupyter Hub pods. So my namespace already has uh, Jupyter Hub. So I'm not gonna run this command in namespace mfsada because that will upset it. I'm gonna install it in a namespace that doesn't have Jupyter Hub. So remember yesterday we used mfsada-dump. You can see here from 17 hours ago I was testing out this this Jupyter Hub inside of it. Now I can test in a different namespace. So I can either uninstall this so you can see in so Helm list. I'm trying to remember if this was the command. So Helm list -n and my namespace. You can see I have a Jupyter Hub here. So you can see here you can just run Helm uninstall. It's okay if you don't know these stuff yet. We'll practice them in a little bit as well. Helm uninstall. And I use the release name, which is my-jh and -nmfsada-dump. And I can just cube control get pods -nmfsada-dump and terminating. You can see it's cleaning up after itself. You can see no resources found. It cleared out the pods. So now I have a clean slate. I can run back to the same command in here. This one, upgrade. I'm going to use mfsada-dump again. Version, use the one we specify in docs. If you want to upgrade to a higher one, that means we still haven't tested it yet. So use at your own risk, basically. Values, this is the values file that I created. So remember the file we edited, the file that has the configs, this one, values.yaml, where we pasted the secret token. This is the values file that we're going to be using. So if I run this as is, it won't find this one. It's called values.yaml for me. So you can see I called the release JH and it's installing. I'm going to leave this installing and look in the other terminal window. You can see it's creating two pods, a hub pod and a proxy pod. You can see proxy is running and hub is still pending. I'm just going to wait on them. You can see now they're progressing. One is running for 14 seconds and one is still container creating. I'm going to wait on them a little bit. So we'll wait for the hub pod. Let me show you. This is sort of a, let me call it Easter egg, but this is a tool called K9S that allows you to see, that allows you to use the Kubernetes command line interface in an easier to view way. So this tool is called K9S or K9s. It's the same thing as kube control, but it shows you a sort of GUI-like interface that shows you what's happening. So this is my namespace. You can see for pods, that one was running in blue. This one was in red. Red means unhealthy and it's still starting up. So if it remains unhealthy for a long time, it shows you error, but turned blue, that means it turned healthy. And if you want to install K9s, we'll happily show you how to do so. But returning here, if I return to the classical kube control method, I can see both are running now. If I run back to my helm command, you can see here, it shows me a Jupyter Hub happy message. You successfully installed. This is the information. And verify web-based access. You can see here you have not configured an ingress. And a lot of things. It says use it at localhost. So if I visit localhost, nothing is going to happen because this localhost is my own computer's localhost. And this localhost is the my Jupyter Hub instance localhost. So this is the local host of this instance. So it's running inside my pod in Jupyter Hub West. So this is not accessible to the outside world. If I want to access it, I can either run the port forwarding command that it's giving me, and go through kube control, or I can configure an ingress. So this is the next part. To configure an ingress, you copy over this part and where are we? Here we go. So to configure an ingress, you just copy over this part to your values file and you scroll all the way to the bottom. You can see as long as the indentation is nice, it will be happy. So if I include it here or here, doesn't matter as long as the indentation is right. So it's not interrupting the calling section, for example. So ingress enabled true. You don't need to care about the rest. All you need to care about is this name to match. So ABC here needs to match ABC in here, and it needs to be unique, not something that is used before. Of course, while you can't peek on what's used and what's not, you can test it out, and if it's not used, if it's used before, it will complain. So let me try mfsada-temp-tutorial and copy this and paste this here. And just purely by adding this, you have the ability to expose your Jupyter Hub that is running as a web service on NRP to the outside world using NRP's domain, just adding your own subdomain. So I added this here. Control S or Command S to save. I can close this. I can run back to the upgrade command, the same one I ran. So the Helm upgrade command that I copied over, I can just run this. This upgrade command will only change what is different now. So right now what it's actually doing is that it's adding the ingress that will expose it. So I'm just gonna wait on it to finish. And we'll give it a minute. I can look here, you know how we were doing cube control, get pods and temp. You can see the new hub has been up for 29 seconds, which means it's probably happy. You can see here, right? The second time around, it doesn't say you haven't exposed it. It says verify web access. Try and secure or secure the HTTPS. This is a public link. You can go to a different country, you can try from a different browser, you can try from your phone, and this is accessible. Now, how do I log in? I run back to my values file. This is what specifies the users. You can see I already pre-created a user called admin, and password is training123. And you can see the images in here, I'm specifying them from the values file. So this is my values file. The images are specified here. You can go through the rest of the document. We tell you how to override the specs. So the images are from here. How much memory and CPU the user is getting is also customizable. You can see in CPU limit and guarantee, that's 3 cores, 10 gigabytes of memory. That's up to you as an admin to change. Who your admins are, you can add emails. So for example, I can add myself as an admin. I can change the password. And a few things to note. So hub, this part here defines something called hub. Hub is one of the two pods. Remember when we ran kube control get pods? Now you don't need to care about what the hub and proxy do, but they're individual pods that are not the user instance pods. So this is hub, and this is proxy. And each of them defines resources being used by each of their pods. You don't need to modify these. By modifying these, you won't get any advantage. These are not your instance. These are the hub and proxy pods. When you start an instance, and let me start an instance to show you, it starts a new pod. So you can see Jupyter Hub dash the username, which in our case is admin. It's starting up in here. We'll wait on it a little bit. But this instance is spawning from what is called single user. So single user, you can see here, it's getting 3 CPU cores, 10 gigabytes of memory. That's because how we specified it. So you can modify this and we'll start with something different. Another thing is that storage. You know how we said in ours, it starts as 5 gigabytes. You can modify that. You can make it 50 gigabytes. You can have more elaborate setups. I'm not gonna waste your time in the call here, but you can do shared volumes as well. So you can tell each Jupyter Hub instance that /home /Jovian is a 50 gigabyte dedicated storage for each user. But on, let's say, /mount, each user gets access to a shared volume that all users can see. So if a user creates a file in here, everybody else can see it. That is 100 gigs, for example. And you can see here, control get pod. Our pod is container creating. You can see here because it's pulling the image. So I can look as an admin. I have two ways to look. I can look from control and I can look from the admin interface. Can click on admin on here and it should list my users. Forget about these ones. I have my admin user. So on Jupyter Hub West, we can do this ourselves as admins. We see your instances on here, and once they start, we have an access server page that we can visit. And you can see here, it's still pulling the image. We'll wait on it. And we'll give it some time. But in the meantime, I'll show you this. So kube control, get pods dash, and Jupyter Lab. You'll see you might recognize your instance in here. For example, here's my instance. This is Jupyter Hub West. It's running in the exact same way. So you have a hub and a proxy pod, and you have the user instances. And likewise, ours is running in our namespace. The Jupyter Hub West is deployed through YAML, same way. This is still taking some time, so we'll wait on it in a little bit. And actually, let's not wait on it because I want to show you uninstalling. So Helm, if you scroll all the way to the bottom, so Helm list dash n mfsada dash temp lists my Helm chart. You can see release name is what I called it, JH, and I can just do Helm install JH dash n mfsada dash temp. And uninstalled means it's starting to uninstall everything. So you'll see my, okay, now it decides to start. This will stop running soon because we uninstalled everything, but basically you can see service unavailable, it uninstalled everything, you control get or Helm list. Oh, sorry. Helm list it should say not here. Now the last and main very, very, very important thing to note in here is that this example in here is purely for training. The reason is because this is not secure. So this can be easily broken into. So if you actually run this on NRP, you will most likely hear from us through email saying you should not set a specific password. You should go through CI logon, just like how everything goes through CI logon. So the steps towards how you go through CI logon are listed in here. So everything is in NRP's documentation. Every single thing that we've mentioned today is in documentation. So we're just trying to provide it in an easier format. But to going through CI logon, here's the link. We tell you how to create your own Jupyter Hub. Same steps we've done today here. The only thing we add in here is that we tell you to go through CI logon. So you can see here, where is it? Register your CI logon application. The reason we didn't do this live is because the first step is to register an application. So you go in, you fill out this form, and you wait to hear back. So that is not something that we can do live. Sorry, you seem to have closed the page. But yeah, this is the doc page to deploy Jupyter Hub. You have it as a reference, not only the notebook we've used today. And this is the doc page. Similar under Coder, there's deploying Coder that shows you how to install Coder. And part five, this is sort of extra if you want to try advanced use cases. And it shows you how to use NRP's GitLab. And you can use NRP's GitLab to build images. So, we've seen how we deployed our own instance that lists images and we have different choices. So where's values.yaml? So we have SciPy, we have R, we have MATLAB, we have different options. They're coming from here. You can see the images, some are being pulled from different registries. You can add your own image, like display. I'll show you an example. So display name, my own custom, and you can add the cube spawner override to here, add the link to your own GitLab image on NRP that you built and you can customize. And this would be a good place to stop in here for the intermediate track. Thank you all for joining in today. Hope everybody had a good experience with deploying. I'm gonna pause the recording here and go into Q&A and we can help you if you're facing problems spinning up.